Okay, guys, sorry those first two videos were so long, but I think it was important that we took the time to go over the graphs. Now, those are something that we should forever have ready and available for us. Now, the second part of this class, we're doing the extra problems. This I expect to go faster, but I always expect things to go faster than they actually end up going, so I won't make any promises. We're evaluating and graphing piecewise function. What is a piecewise function? It's just a function with different rules for assigning output values for different parts of the domain. And since it's split into different pieces, we call it piecewise function. So the x values where the formula changes from one rule to another, those are called transition values. So look over here, that would be like, in this first example, transition value with 0. These points could be open or closed depending on how the rule is defined. So if you look at this, if it includes the equal sign, then it's a closed point. And if not, it's an open point. Okay, we're going to go right to graphing these guys. And we'll treat number 1 as the example. And then you can try the rest of them, like usual. So it's to sketch, determine the domain range, and intervals like increasing, decreasing. Okay, so we're going to try to blast through these guys. I'm not going to give a super detailed graph because we spent so much time graphing in the beginning. So now is when we just go straight to work. This says for x less than 0, you define it as 2x. So that means to the left of 0, right? So what is 2x? 2x is just a line, and it's got slope of 2. So it should look something like this. And I continue the graph up until I hit 0. So that's the first half of the graph. Okay, second half of the graph will be in blue. From 0 onwards, it's x squared. X squared we know looks something like this, right? Remember? This time equals to 0. It's greater than or equal to 0, so that means at that point you would fill in the circle. It just so happens this circle that's filled in coincides with the left half of the graph, so they're just one continuous graph in the end. So there it is. That's number 1. Now domain and range, I'm going to just write D for short for domain. That's going to be everything, negative infinity to positive infinity. And R for range, that's also negative infinity to positive infinity. Increasing, decreasing, it's increasing I and C for short from the whole time, right? Negative infinity to positive infinity. So that was easy. Okay, on to number 2. So erase my work so I can make more space. Okay, I have 2 graphs. 1 over x, one of our good friends now, and square root x, another one of our good friends. The transition value is x equal to 0. That's where it switches from one to the other. At less than 0, it's 1 over x. Remember that graph looks like this, right? And it's not the squared one, it's the regular one, so it's negative. Approaches the asymptote right here, right? That's for less than 0. And then once you get to 0, then you're a square root of x, including 0, because this is an equal sign right there. So here, square root of x looks something like that, remember? So there's your piecewise function graph. Now, where's the domain range? Domain, everything to the left, everything to the right, including 0, because 0 is defined right there in that center dot. So you get everything. What's the range? Range, got everything to the bottom, as low as I want. I go all the way up closest one to 0, and then I get 0 itself. And then I go on upwards forever. So the range is also everything. Increasing, decreasing. So from the left to the middle, it's decreasing, right? So DC for decreasing, negative infinity up until 0. And where's it increasing? After that, it's increasing. So increasing from 0 to infinity. Okay, so that's number 2. So now that we've gone through the work of getting familiar with our graphs, we have the general picture pretty easily, right? Okay, here's number 3. Okay, if you're less than 1, so 1 is the transition value. Here's 1. And if you're less than 1, you should be absolute value of x. Remember absolute value of x? That looks like a V, centered at the origin. So right there. Open circle because this is a less than sign, doesn't have the equal sign on the bottom. On the left of the V, it looks like that, right? Okay, once you get to 1 onwards, you should be x cubed. X cubed, remember, it looks like this, right? It goes up like this and down like that. But I don't want the whole thing. I only want to start from 1. So at 1, x cubed is 1. It goes up like that. Now we fill in this circle because greater than or equal to 1. Means I include the actual value. So that's it. Okay, domain, everything. The range, I have 0 and everything above it, but that's it. Decreasing from the left up until you get to the center, right? So negative infinity to 0, and increasing from 0 on upwards. So there you go. Okay, you know, for these guys, you know, if you're ever stuck and you don't remember the graph or anything, you can resort to what we did earlier when we were going over the individual graphs and just make a table of values. So let me show you that as an example in this next one. Actually, maybe, you know, 4 is not really a good one because I don't like to make tables of values for the greatest integer function if I can avoid it. So I'll show you what I mean in number 5 instead. Here's number 4. Okay, so 1 is a transition value, right? So at 1 is where I switch from one to the other. The greatest integer function for things less than 1. Okay, what is the greatest integer function? Remember, I always start by just plotting the points 1, 1, negative 1, 1, negative 1. Things that are right along the origin that are integers, because that's what I get, right? And if I have a larger value, then I'm going to take the smaller of those two. So if I input something like 0.5, the output should be 0. So it's a line that goes to the right. And then it's an open circle here, well, for 2 reasons. One, because, you know, open circle, if I at 1, the greatest integer function would be up here at 1, not here down at 0. But for the other reason is that this is only defined as greatest integer function for values less than 1. So for sure, this is an open circle. But this is also an open circle this direction here, like this, right? These are horizontal lines. Okay, what about after that? So after that, I have the cube root of x from 1 onwards. So what is the cube root of x? Actually, you know, this is a good spot to make a little table. So I want the cube root of x, but only for x that's 1 or greater. So 1, cube root of 1 is 1. And next thing I can take of cube root easily would be 8. Cube root of 8 is 2. So 1, 1, right? And 1, 2, 3, 4, 5, 6, 7, 8, and 2. Okay, my scale is off, but, you know, general idea like that. And then remember the cube root function looks something like that, yeah? The actual cube root function goes like this, right? But I only want this piece from 1 onwards. So there's my graph. Okay, now that I have the graph, let's answer the domain, range, and increasing, decreasing questions. So starting with the domain. Domain, I get everything. Because look, x could be anything, right? To the left, I get all these x values, I get all these x values. And then from here on, I get all the x values. So domain is actually everything, surprisingly. Surprisingly, because it looks like it's so disjointed, but it's okay. I got all the x values possible. The range is in 2 parts. So first, you get all these integer values to the left, right? So you have dot, 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 -3, -2, -1, you got 0, and then that's it for the first half of the graph. And then from 1 onwards, you have everything. So those individual values unioned with 1 onwards to infinity. That's the range. Okay, constant, increasing, decreasing. It only did us. Oh yeah, it asked for constant part 2. So this part's a little tiny bit tricky. Not that tricky. If you remember the greatest integer function, constant intervals, That's the hardest part. But we did it before. So I'm going to go with constant first. Because there's no part where it's decreasing. So where is it constant? Constant on all these intervals, right? So actually it's not so bad. Let's write it like this. Dot, dot, dot. -3 to -2. Union -2 to -1. Union -1 to 0. Union with 0 to 1. Okay, that takes care of the step function portion. And then now it's increasing. Where is it increasing? From 1 onwards, right? So from 1 onwards to infinity, it's increasing. Okay, that was number 4. All right, and we're, oops. Not sure if this erase is gonna work. But let's just try it out. Oh, it worked. Okay, great. Okay, number 5. Got an absolute value and a square root. And this time, if I look at my range, I'm not going all the way to the left. I'm stopping at -2. So we have like a finite cutoff. What does that do? Okay, don't worry about it. It's not hard. It just means I only start from -2. And then the transition value is at 1, right? So for this value goes up to 1 for that function, and then from 1 onwards is a different one. So 1 is the transition value. Absolute value from -2 is a -2. Absolute value function, remember, oh, sorry guys, I shouldn't label this with red. Absolute value function, remember, it looks like a V, right? Starting at the origin. I'm only doing this up until 1, and then up until -2. -2 less than or equal to sign means I fill in that circle. So include that point. And then from 1 onwards, it's the square root function. Square root of 1 is 1, so fill in that circle now. And then I take the square root function, looks like that. Okay, answer the questions now. Domain is, this time starting from 2, -2 I mean. And then onwards forever. The range, the smallest it gets is 0. And then it gets as big as you like. Okay, we're decreasing from -2 up until 0. And then after that, we're increasing. Okay, that was number 5. Okay, in this video, I'm going to do up through 8. And in the last video, we'll do the last 3 questions about the graphing. I think that last video will be easy one. Okay. I think my coffee is wearing off. I'm talking slower now. Okay, that was number 5 we did, right? Okay, so here we go. We're taking g of x. By the way, nothing sacred about the names. Sometimes it's f, sometimes it's g, but who cares? We're just graphing the y's and x's anyway. So we're treating the function values as the y values. I haven't been writing my x and y. My old Calc 3 teacher used to get really honest about making sure you label your graphs, and a lot of times I forget to do it. But it's technically wrong if you don't, I guess. Okay, so -8 to +1. That's our first interval where we're gonna graph cube root. 1, 2, 3, 4, 5, 6, 7, 8. And they chose -8 strategically because what's the cube root of -8? It's gonna be -2. Let's go ahead and plot that point already. And that's including that boundary point. At +1, that's where the switch occurs. Okay, so finite graph here. Don't go past -8. The cube root should pass through -1, -1, and 1, 1, except at a circle because it's not including that point. So it looks something like this, right? That's the cube root portion. And then after that, it should be 2x for 1 or greater. Now, what is 2x if I plug in 1? If I plug in 1, I get 2, right? So this was 1, 1. This is 2. Plugging in 1 as x, 2x is going to give me 2, so that means I have a little jump here to there. And then from there, it's 2x, that one. Okay, that's my graph. Do all the answers now. So the domain, sorry, capital D for domain. Domain is from -8 to 1, and then from 1 onwards. So there's actually no gap because 1 is covered with an x value. So that means from -8, oops, infinity looks like an 8 on its side. So I wrote infinity. -8 to infinity. The range is from, let's see, -2 up until 1, right? So -2 up until 1, but we don't include 1 because it's got a hole. And then union from 2 onwards forever. That's the range. Increasing, it's never decreasing, never constant. It's increasing on exactly the same spots as the domain. Almost, actually, no, yeah, not quite, because -8 until 1, it's increasing, right? Oops, sorry. For increasing intervals, open parentheses, yeah. -8 till +1, and then union from 1 onwards forever. Yeah. All right, 2 more in this video. Okay, our first 3-parter. Yay. So we have a piecewise function in 3 pieces this time, but you know, go about it the same way. It's really pretty much the same concept. I've got to go, I don't have to go too far to the left because the most leftmost transition point is -1. So here's the first transition point at -1. And then I have another transition point at 2. So for x less than or equal to -1, it's -2x plus 1. So what I'm going to do is I'm going to graph that first. 2x plus 1, that's intercept of 1, and -2 slope, right? -1, -2. Right? This -1 is in my way. So I'm going to go 2 down, 1 over here, right? Okay, for now, I'm just graphing the way that's easiest to graph. Once I actually graph the thing, I'm not going to graph this whole line because it's only from -1 onwards to the left of that, right? Okay, so this is the intercept with the slope of -2. Oh, I'm sorry, guys. I'm sorry. I made a mistake. Sorry. This is a -2 slope. So it should be 2 up, 1 left. Or you can think of 2 down, 1 right, right? So that should be the slope. So my graph of the line should look something like this, right? But remember, this is only for -1 and onwards to the left. So that means I should start from -1 position, or sorry, x value is -1. And then onwards to the left. So that should look something like this. Okay, that takes care of this portion of the line. Okay, next part of the line, this part we'll do in blue. This is 2x plus 1. Okay, so same intercept right here, right? 2x is a +2, so +2 slope. And that goes from -1, but open this time. Oh, I'm sorry. Again, it's getting my way. It's a -2 slope, so 2 down, 1 to the left. That should be right here, but open circle. And then 1 over 2 up, so here. And I continue that pattern up until I hit 2, so that should be over here. Okay, so this is the second part of the line. That takes care of this portion from -1 to +2. And this one should have been open circle as well, because these are strict inequalities here, so I'm not including those boundary points. Okay, lastly, x plus 2 for x greater than or equal to 2. So I'm going to do that in a third color. Blue plus red makes purple. So x plus 2 means intercept of 2 right here, right? slope of 1. So 1, 1 would be here, 2, 2 would be there. Oops, sorry. Turn off my notifications. So there, and then so that would be the whole line, right? But I don't want the whole line. I just want it from 2 onwards. So it should be right here, and then slope of 1 onwards that way. It's actually pretty cool. Oops. It's actually pretty cool once you plot it. All right, so now let's answer the domain range questions and intervals increasing, decreasing. So domain, first of all, okay, everything to the left, right? This goes onwards forever to the left. At this position, I have something defined there, no problem. In between, got something covered, everything's covered, and onwards to the right, everything's covered. So domain is everything. Okay, what about the range? Well, range, for sure, I don't go past this point. Is that -1? Not including -1. And then it goes up. Over here, it looks like I got a gap, but it's covered by that portion and also covered by that portion. So everything above -1 is okay for the range. Okay, what about increasing, decreasing? Let's do decreasing first. Decreasing this is the only portion where you're decreasing, right? Where you have the negative slope. That's everything to the left of -1. And then increasing from -1 till +2. And then again from +2 onwards to infinity. That's increasing. Okay, guys. One more for this video. Okay. So number 8. Okay. Typical kind of question. Another step function. Oh, and transition right at 0. So that's nice. Okay, for less than 0, 1 over x. Remember our good old friend that looks like this, right? Here's -1, +1. I mean, -1, -1. Yeah. And then from 0 onwards, step function, including the point at 0. So 0, remember, 0, 0, right? 1, 1. You get 2, 2. Step function goes to the right and it has got a hole like this. So, oh, done. That's the graph. That was easy. Okay, domain. Everything to the left, up to 0. You do get 0 itself, so everything. -infinity to +infinity. The range. Okay, you get everything down below, up until you hit 0. So looks like -infinity to 0. Now, do I include 0? Yes, because there are values that do give me exactly 0. So including 0. And then union with all those individual values after. So 1, 2, 3, and so forth. 4, 5, 6, 7, 8, 9, 10. Okay, great. Okay, increasing, never. Decreasing for that first portion. So decreasing from -infinity up until 0. And then constant on those step function intervals. So 0 to 1, 1 to 2, 2 to 3, etc. Yeah. Constant. Okay, that's it, guys. Whew, that was exhausting. Let's take a break.